Hello everybody. In this example, we're going to look at topic 3, lesson 4, example 1, using long division to divide polynomials, and we're in the enVision's Algebra 2 math book. So let's remember the algorithm for long division. Let's say I had 84 divided by 7. Well, I'm going to place it into the format for long division where I have the dividend inside and the divisor outside. The I call it a little house. And then the first thing I'm going to do is I'm going to look at the first value in my series here, and this is 8. So I'm going to do 7 divided by 8. 8 divided by 7, and we get 1. So I'm going to place that 1 right on top of this value of 8. And I'm going to do 1 times 7, and 1 times 7 is 7. And then I'm going to change the sign of this. I'm going to change it from positive to negative. And the whole reason I say I'm not going to say I'm going to subtract it is because when we go into the polynomials, you want to change the sign. You want to do the opposite sign here. So 8 minus 7 is 1. Then I'm going to bring down the next term, or the next value here, which is 4. And again, I'm going to repeat that process. 14 divided by 7 is 2. Place the 2 above the 4. 2 times 7 is 14. Then I'm going to change the sign. And in this case, I have no remainder. So we're going to use that algorithm to solve for, to find the quotient for our first part here. So how can you use long division to divide p of x by d of x? Write the polynomial p of x in terms of the quotient and remainder. So in this case, we might have a remainder. So this is my divisor, this is my dividend. So I'm going to do x plus 3, and I'm going to divide that into x cubed plus 5x squared plus 6x plus 9. Now here, what I'm going to do is I'm going to just pay attention to the leading term. And in this case, my leading term is just x. And I'm going to take that leading term and divide it into each of these. And then when I do the multiplication, that's when I pull in the second term here. So the first thing I'm going to do here is I'm going to take the x cubed. I'm going to divide it by, so I'm going to take the first term and divide it by the leading term here, x. And I get x squared. All right, so I'm going to put x squared above x cubed. All right, so then I'm going to do x squared times x. X squared times x is going to be x cubed. And then I'm going to multiply that x squared times 3. So I get x squared times 3, which is 3x squared. What I'm going to do is, with a different color to ensure that I have changed the signs, I'm going to change my signs. So this is no longer a positive, that is now a negative. What should happen is the first terms here should fall out. They should become 0. And we do. We have 0 here. X cubed minus x cubed will be 0. X cubed. Or just 0. And to keep things clean, I'm just not going to write it down. I just know they cancel each other out, or they become 0. So now I'm going to do 5x squared minus 3x squared, which is going to be 2x squared. Just like before in the previous algorithm, we're going to pull down that next term, or that next value. All right, so now the second part here is I am again going to repeat what I did in this step here. So I'm going to take the leading term here and the leading term here. I'm going to divide those out. So we get 2x. Positive 2x here, because this again is positive. We have a positive 2x here. 2x times x will give me 2x squared. 2x times 3 would give me 6x. Change the signs. And we actually get 0 here. Pull down the 9. And this 9 now becomes our remainder. And it's the remainder because if I do 0 divided by x, I get 0. So this would be a plus 0. And then we'd have 0 plus 0, and then we'd still have 9. The 9 would remain. So the way I'm going to write this is I'm going to write x squared plus 2x plus 9 over x plus 3. Or you could also write it as x squared plus 2x with the remainder. So let's go back to the book and see how they write it. So there's x squared. They pull down all the terms. Again, I just pulled down the one term. Divide again by x. We get that. And then we get the remainder of 9. So how they wrote it here is going to be the dividend divided by the divisor equals the quotient plus the remainder over the divisor. Or we can put this in kind of a factored form where you have the dividend equals a quotient, which is the x squared times the divisor plus the remainder. So what they did here is they took this, and instead of dividing it on our remainder, we're going to multiply it to my quotient. So this format is known as P of x. Oh, I don't know why I put more parentheses. Times Q of x plus R of x. Or actually in our case, let me rewrite this. Sorry, let me rewrite it. This is our quotient, Q of x times our divisor, D of x plus R of x with our remainder. So quotient times the divisor plus the remainder. So two different ways to write this. This is again our quotient. So this is going to be Q of x plus R of x divided by D of x. So different ways to write this. And again, it's communicating with math. This is where you learn the math terminology and how to communicate this shorthand way of writing math terms. All right, so in this one, we are looking again at P of x divided by D of x. Oh, that just looks, let me clean this up a little bit. I just didn't like how that wrote out. So we have 8x cubed plus 27. All right, so again, I'm going to follow the algorithm. I'm going to do 8x cubed divided by 2x, and we get 4x squared. Well, I noticed something here. So when I multiply this, we're going to get 8x cubed plus 12x squared, but I'm not subtracting from a 12x squared up here. I'm subtracting from a 27, so we can't actually do that. What I'm going to do here then, since that's not possible because you have to subtract like terms or add like terms, I'm going to put some placeholders here. So that, again, I'm in standard form. My exponents are counting down, exponent of 3, exponent of 2, exponent of 1, and exponent of 0. And now I'll be able to line these up. Change my signs. So we're going to get negative 12x squared here. Bring down this term plus 0x. And I'm going to repeat the process. Negative 12x squared divided by x, 2x. And I get negative 6x And I'm going to put negative 6x here. Multiply that out, we get negative 12x squared minus 18x. Use red to change my signs. And now I'm looking at 18x here. Pull down that 27. And then again, repeat the process. 18x divided by 2x. And I do the process here on the side. So that's 9x. Plus 9x here. 9x times 2x is going to be 18x. 9x times, oh, I like how I got the x there. It's not an x. The x's cancel out. This is what happens when you do some math so early in the morning. 9 times 3 is 27. Change your signs. And we get 0. We get no remainder. So I'm going to write it in the qx plus rx. I guess we're going to use capital up because they use capital letters, divided by dx, which we're going to see as 4x squared minus 6x plus 9. And then we don't have a remainder, so this would be 0 over 2x plus 3. And we don't really have to have that in there, so I'm not going to include it. The other way we could write this is 4x squared minus 6x plus 9 times 2x plus 3 plus 0 for a remainder. So this would be the qx times dx plus rx. All right, so let's go to the second part of this. Look at their solutions, and there you go. They wrote it as the qx times dx. Notice the difference between the two of these. This one is actually having the dividend there, or the divisor there. Here we have the divisor here. So when you write it fully out, make sure you include the divisor if you're using the first method. The second method basically multiplies that divisor over. All right, so generalize, when the remainder is 0, you can use the result of the long division to write p of x in factored form. All right, guys, so you do have some try it, so try this out. Make sure you follow the long division algorithm, and I will see you in the next video.